Yes, sir.
Yes, it is, sir.
It's visible?
It is.
Great. So this was our topology. Here we had enabled MPLS between router 1 to router 5. Then we had seen packet flow over MPLS like label based forwarding on router. Yes. So what I told you, as soon as you will enable MPLS on a router, router will attach one label with all the prefixes present in routing table or with all the prefixes present in table SAP table or routing table. You can control it, like if you want router 1 should only attach label with this prefix 10 prefix, you can do that, you can control that. What label it will like attach? It will attach label from the range. We know label, like we have 20 bits for label. We have 20 bit range is 0 to 2 power 20, and 0 to 15 label are reserved. First 16 labels are reserved. Guys, I'm sorry I'm not able to speak properly, right? There is some issue in my voice today. Continuously speaking in hospital since morning. So please manage. Okay? I am trying my
It's
best.
okay. We can hear you. It's okay.
Yeah, it's no worries. No problem.
Okay. So okay, so when router will attach label, after that all the routers are going to exchange label with each other with the help of two protocol, TDP and LDP. TDP stands for tag distribution protocol, which is Cisco proprietary protocol, and TDP is not in use nowadays. Commonly we are using LDP protocol to advertise label, correct? When router attach label with prefixes, then we called router maintain LIB table, label information base table. LIB table, but router doesn't use LIB table to forward traffic. To forward traffic, router calculate what? LFIB table. It is similar like EIGRP database or OSPF database and OSPF routing table. In the LIB table, router can have multiple remote label, but it will install best label in the LFIB table. And how router take forwarding decision? It router, whenever router receive labeled packet, it compare local label, find remote label and exit interface, then take forwarding decision. For an example, if 10.1 want to talk with 20.1, source IP 10.1, destination IP 20.1. Every time whenever you are learning any protocol or any technology, if you will check packet flow, you will understand that technology in better way, right? Similarly in MPLS, if you will check packet flow properly, you can understand MPLS properly. Okay, so on router number 1, you know router 1 is receiving unlabeled packet, normal IP packet. This is not labeled packet. User is not generating any label packet. So router 1 is going to compare destination with their SAP table. So IP SAP and 20.1.1. It will understand that. Here you can see for this destination exit interface is fast Ethernet 1/0, and if there is label, it means a router is going to attach label. If I will capture this link, if I will capture this link, and then if I am going to ping 20.1 source 10.1, here you can see the label. You can see my all ICMP packet, right? Let me open first ICMP packet. Here we don't have any label. This is IP header, Ethernet header, and ICMP packet, IP header, Ethernet header, and frame. It means we don't have any label here. Why? You can see here label. Don't know why. I think I had opened wrong packet. If you will open ICMP packet here, in some packet, I think this is reply packet. Okay, from here if you will check, here you can see where MPLS header is attached between Ethernet header and IP header. That's why sometimes you know what we called MPLS take forwarding decision at 2.5, but you know in OSI model or TCP IP model we don't have any 2.5 layer. So actually it is running between Ethernet header and IP header, means between layer 2 and layer 3. Inside the MPLS header you can see we have label number 205, the same label you can find in SAP table 205, right? This is remote label on router number 1. You can find this in LFIB table as well. So MPLS forwarding table. So MPLS forwarding table, here you can see for 20.1.1.0 remote label outgoing label is 205 and local label is 105, because we can also control this, right? Router should attach label from which range. By default router is going to attach label from 16 to 16 17 till 2 power 20, but you can control that. Here yesterday I had configured label range on router number 1 is 100 to 199, on router number 2 200 to 299, like that. So that's why you can see router 1 has attached 105 and router 2 has attached 205. So router 2 is advertising this label. This label is remote label on router number 1, right? So it has attached same label in the MPLS header. Then experimental field, I had told you we have 3 bits for experimental, that is used for QS, right? By default not in use. Experimental 3 bits, all are off. For label we have 20 bits, you can see, and the value 205 in binary. Then I had talked about S bit, if you remember. S bit, MPLS bottom label, like the last label. So S is 1, means this is last MPLS header, and then TTL 5 bits. These are the fields in MPLS header, correct? We are discussing.
Yes, sir.
Router 1 has attached label what? 255. Actually router 1 has not attached this TTL. Router has copied this TTL from IP header. It has copied TTL from this IP header. TTL value in the IP header is 255. It has just copied. If you will check capturing, if you will capture this link between router 2 and router 3, let's say, let me capture this. And again I am going to generate ICMP packet. Again let me open any ICMP packet. Here you can see the MPLS header. TTL value is decremented by 1. Here TTL value is 254. But inside your IP header TTL value is still 255. Means router 2 didn't decrement in TTL inside IP header. It has decremented in TTL in MPLS header only. If I will trace route 20.1 from router number 1, trace route 20.1.1 and source 10.1.1 numeric, then you can see here. First hop is 12.1, second hop is 23.3, 23.3 is router 3, router 2, then router 3, then router 4, and then router 5. So actually we got trace route, like all the hops in trace route, because it is giving me the information based on TTL value inside the MPLS header. If this is C router and this is another C router, this is P router and P router, you will never discover P router, customer cannot discover P router. Why? Because in that case there will be two MPLS header. When again I will configure MPLS L3 VPN, and there I will show you multiple MPLS header. Here we have not configured PNC or customer and provider network. Just to understand the fundamental, I have connected 4 routers, I have enabled the MPLS, and we are understanding the flow. So based on MPLS header, it is tracking all the hops, but inside the IP header you can see TTL value. Inside the IP header is same. Router 2, router 3, router 4. These routers will not decrement in TTL in IP header. Only router 1 and router 5 will check TTL value inside IP header. Inside IP header. Then one more thing we have discussed. So MPLS LDP binding. Which table it is? This is LIB table. How router exchange LIB table, or how router build LIB table? With the help of LDP. LDP. You don't need to learn TDP, tag distribution protocol. So let's suppose I have two router R1, R2. Like we have OSPF neighborship, EIGRP neighborship, BGP neighborship. Similarly, here we will have LDP neighborship. There are two ways to configure LDP neighborship: static and dynamic. In OSPF also, you can configure OSPF neighborship statically as well as dynamically. Like OSPF elect router ID, similarly LDP also elect router ID. LDP stands for label distribution protocol. It works at, it is layer 7 protocol. Sometimes people are saying LDP is layer 3 protocol. No guys, LDP is layer 7 protocol, works at application layer. Then if it is application layer protocol, then which service it is using at transport layer? So it uses TCP at
TCP.
transport layer. TCP, it uses both TCP as well as UDP. Port number, anyone have idea about port number? 646. In case of TCP as well as UDP, port number 6464 is reserved for LDP, like HTTP, HTTPS, Telnet, SSH. Port number 22 is reserved for SSH, 23 is reserved for Telnet, 443 is reserved for HTTPS. Similarly, 464 is reserved for LDP protocol. Now, let's suppose here I have enabled MPLS and IP address is 12.1, IP address over here is 12.2, and you have enabled MPLS. Automatically it will enable LDP protocol. If there is any loopback like on router number 1, 1.1.1 and 2.2.2, then make sure both the loopbacks are reachable with each other, because loopback IP address is going to be LDP router ID, and router ID of both the router should be reachable. Okay, so LDP router ID of router 1 is 1.1.1, LDP router ID of router 2 is 2.2.2. You can also change LDP router ID manually. If you want to configure something else, you can do that. Otherwise, like OSPF elect router ID, similarly LDP also elect router ID. Done. As soon as LDP is enabled on the interface, both the routers are going to send LDP hello message, similar like OSPF hello message. This hello message is going to be UDP based. UDP based hello message. UDP based hello, hello. R1 will send hello message to R2, R2 will send hello message to R1. Inside the hello message, there will be some information like LDP identifier, LDP router ID. But when this LDP hello message will send after enabling Mpls, and this time router are not going to establish any three-way handshake or TCP connection. Why? Because this is UDP based. So in case of UDP, we know UDP is not reliable communication. So directly, as both routers are going to exchange hello message, they will check some parameter will match, and both the router will become neighbor. It will form relationship, neighborship. After becoming neighbor, when both the routers are neighbor, LDP neighbor, then routers are going to send SYN message. Router 1 will send SYN. Any one router can send SYN message first. Another router will send SYN plus ACK message. We have already discussed these all things. These are basic for you guys. SYN plus ACK, and then finally router 1 will send acknowledgement message. Now router 1 and router 2 has TCP connection. Now TCP session is established between 1.1.1 and 2.2.2. TCP connection. TCP. Now port number is reserved. And now with the help of LDP message, both the routers are going to exchange label like LIB table. And this message is TCP based. This is TCP based message. That's why I'm saying LDP uses TCP as well as UDP. This TCP message is used to share label information exchange message. Label information exchange message, both the router. So router 1 is going to share their own label, local label, that will become remote label for R2. R2 is also going to send their local label to R1, and for R1 that will become remote label. For an example, there is one subnet 10.1.1.0/24. Here is one subnet 20.1.1.0/24. So in the routing table of router number 1, we have two subnet 10.1.1.0/24. Their local label is 101. By the way, for directly connected network, routers are going to attach label null. It will not advertise any label, but I am assuming here label is 101, and for 20 submit 20.1.1.0/24 label is 102. Similarly, router number 2 10.1.1.0/24, their local label is 201, and 20.1.1.0/24 their local label is 202. So with the help of this TCP label information exchange message, both are going to exchange this table, LIB table, and then both the routers are going to build LFIB table. How it will find the best label? Like this, 10.1.1.0/24. Now there are two label, one is local label and one is remote label, 201. For 20 network also 20.1.1.0/24, one is local label and one is remote label, 202. And you know, when there are multiple remote label, then how router find best remote label? With the help of guys SAP table.
SAP table.
Yes,
SAP table.
with the help of SAP table. And if I will talk about the hello time of LDP, 5 second, hold on time, 15 second, multicast, these messages are multicast. LDP sends their message on this multicast address. The very first message, hello message, on multicast 224.0.0.2. This multicast group is user for LDP. You can verify this. What you can do here, you already have capturing between router 1 and router 2. On router number 1, I think I have one loopback as well. So IP interface brief 1.1.1, you can see. So Mpls LDP neighbor. If you will check local identifier 1.1.1 and peer identifier 2.2.2. Great. Now for an example, I am going to set the port interface F1/0 shut down. LDP session is down. Reachability gone. And now again when I will up the port, both the routers are going to exchange LDP message. Now you can see finish message, right, to reset the connection, to terminate the connection. Now again I am going to say no set. Here is the LDP hello message. First of all, gracious ARP happens, like to check duplicacy. Okay. After that, you can see 12.1 has here their very first LDP hello message. If you will open this hello message, close this IP header, you can see this is UDP based and port number is 646. I am so sorry. It is 646 port number. Okay. And in the UDP header, nothing is there. Here is the LDP hello message. You can see in the LDP hello message also few informations are there, like router ID, LSR ID, then label space, and here is the hello message, length of hello message, type of message, and nothing else, nothing important. Address, LDP identifier. Both the routers are going to send this hello message. After that, they will form TCP connection. Right here is the hello message of I2, router 2. Then here is TCP SYN message, SYN plus X. Here you cannot get the exact output in the Wireshark, but both the router will properly send exchange or perform three-way handshake. Both will establish TCP connection, and once TCP connection is established, after that somewhere you can find label exchange message. Which message it is? This is labeled exchange message. Here you can see router is exchanging label for all the prefixes. Here it should show prefix as well. IPv4. They are exchanging hello message. Okay, that is fine. One minute. Here it is. With prefixes, it is going to advertise. All the routers are going to advertise label. Mapping is not showing properly here in the capturing, but address, message, label, mapping. If there is something else, this is hello message only. Why router is sending reset message? Okay, like through CLI you can verify, no problem. Here you can see MPLS LDP neighborship is up. So MPLS LDP neighbor, this is first verification command. If routers are not exchanging label, if router don't have label, then they cannot take forwarding decision. Let's say any P router in service provider network don't have label for the destination network, so it will drop the traffic. How you will troubleshoot? Before troubleshooting label or LIB or LFIB table, you will troubleshoot LDP neighborship. This is a command to verify MPLS LDP neighbor router ID. And if LDP neighborship is down, check reachability. Then there should be reachability. If there is reachability and if you have configured MPLS properly, then LDP session will be up. There are some more verification command, guys. One is show MPLS LDP neighbor. One is show MPLS LDP neighbor detail. Here you can check the detail information of neighbor, like the hello time, hold on time. Even you can change those all times. One verification command is show MPLS LDP binding table, which is your LIB table. One command is show MPLS forwarding table, used to check LFIB table. And even if you don't want your router to copy TTL value from IP header, there is one command. You can say no MPLS IP propagate TTL. After running this command, router will not copy TTL value from the IP header. Right? One more verification command, like to check MPLS is enabled on the appropriate interfaces or not. So MPLS interfaces. You can see MPLS is enabled on both interface on router number 1. If you are running OSPF routing protocol as IGP, then you can enable OSPF through, MPLS through OSPF also. Inside OSPF there is one command, router OSPF 1, and here is one command, MPLS LDP auto config. What this command will do? This command will enable MPLS and LDP on all OSPF enabled interfaces. Getting my point? Then there was some command, like one command to change the protocol, MPLS label protocol, right? Like this you can change the protocol. You can use LDP or TDP, but I already told you TDP is not in use nowadays. Then there was a command to set the label, MPLS label range. Right here you can define the range, like router should attach label from which range, and here you can see the range of label. 0 to 15 are reserved, so 16 to 2 power 20 you can use any label. Now if you want to control the label, I want a router should not attach label with all the prefixes, or router should attach label 0 implicit null with any prefix. You can do that, but first you have to make interesting traffic with the help of ACL, with the help of access control list. For an example, what I want, my router 1 should only advertise label for specific prefixes. I want to tell to router 1, hey router 1, advertise label with specific prefixes only. Let's say with 10.1.1.0 only. So simply I can create one ACL access list number 10 permit and 10.1.1.0 while comma 0.0.255. Okay, and now I can use this ACL in MPLS LDP explicit null for ACL number 10. For you can see access is number 10. So whatever prefixes will match in ACL number 10, it will set label implicit null. Doesn't matter network is directly connected or indirectly connected. Even I can set range of ACL from 10 to 20. Or if you want to set label, any label, like for manipulation, you can do that as well through ACL only. One more thing, manually also you can set LDP router ID, MPLS LDP router ID. I can say use router ID, loop back to interface, forcefully force. So now doesn't matter where highest IP address is configured. It will use loopback to IP address as router ID. Loopback to is down. So we have this manipulation option. Even you can configure password in MPLS. Yesterday we had not covered this part, but guys, this is just practice. Commands are available. You can practice it like MPLS, LDP, neighbor. See here we can configure a static neighbor also. Even for dynamic neighbor, I know router 1 has one neighbor whose router ID is 2.2.2 LDP identifier. I can configure password for this neighbor. Password Cisco 123 to secure our LDP protocol. And then you can clear LDP neighborship. If you want to configure a static neighborship, MPLS LDP neighbor 2.2.2.2 targeted. This is the command to configure a static LDP neighborship. Now you know how to set implicit label for any specific prefixes. Label 0 is called implicit label. Now if I want router to not send or advertise any label, can we do that? Yes, you can tell to your router to not add label with any prefix. No, actually by default this command is running mpls. Later you guys can go through recording to see the command. Label advertise, label advertise command is not there. mpls LDP advertise label. Yes, by default this command is enabled. That's why routers are advertising label. If you will remove this command, now router 1 will not advertise any label to their neighbor. No. If you want to advertise, then use this command. By default this command is enable. Now I want router to advertise label for specific prefixes. Let's say with prefix which is matching in ACL number 10. So what I can say, MPLS LDP advertise label for ACL number 10, for access list number 10. Now whatever prefixes will match in ACL number 10, router 1 will advertise label for that only to their neighbor. Clear guys, this manipulation?
Yes, sir.
Right? Easy, but you can practice. Important. Many times you have to use it. But I didn't configure anything. Now I am going to change this scenario. Let me start this router. Again, on router number 1, I am going to remove MPLS. I will say no MPLS. I am assuming this is C router, customer edge router, and this is another C router. This is P router, provider edge router. P, P, and P. Provider. You know how service provider is going to separate the customer with the help of VRF? Service provider will create first VRF for customer, yes na? Let me take you to R1 and go to router number 1. Say no router OSPF 1 interface range F0/0 and F1/0, no MPLS IP. On router number 2 as well, interface F0/0, no IP OSPF, 1 area 0. I have removed OSPF from here. On router number 2, I have one loopback 2.2.2. And OSPF is enabled over here. Do so IP interface brief loopback, and do so IP OSPF interface brief. Done. Do so Mpls interface. Mpls is enabled. Interface range F0/0 and F1/0. No Mpls IP. On router number 2 also, interface range F0/0 and F1/0. No Mpls IP. R4. On router number 4, I'm going to get one loopback 4.4.4 for MPBGP. So interface F1/0, no IP OSPF, 1 area 0. Do so IP OSPF interface brief. OSPF is enabled on loopback 1 4.4.4 and on F0/0. Done. And do so MPLS interface. MPLS is enabled. Interface range F0/0 and F1/0. No MPLS IP. Done. Now on router number 5 also, simply I'm going to say no router OSPF, no router OSPF 1. I have disabled the OSPF because these are C router, customer is router. So service provider means R2 is first going to get VRF IP VRF A RD11 and route target both 1:1. Exit interface F0/0 IP VRF forwarding A, no shutdown, and IP address 12.1.2.255.255.255.0. All good. Similarly, R4 will also create one VRF for customer IP VRF A 1:1 and route target both 1:1. Here I have single customer, so that's why I have single VRF. Interface F1/0 IP VRF forwarding A, no shutdown, and IP address 45.1.4 255.255.255.0. Done. Now you need to configure routing between customer edge and provider edge. Let me use BGP protocol. Let's say service provider is using BGP number 500, and customer is using BGP number 100. So on router number 1, let me enable BGP, router BGP number 100 and neighbor 12.1.1.2 and remote AS 500 and network 10.1.1.0 mask 255.255.255.0. Exit. So IP BGP. Good. Customer don't know anything about VRF. Similarly, router number 5 is another customer edge router at different site. So router BGP number 100, neighbor 45.1.4 and remote AS is 500, network 20.1.0, mask 255.255.255.0. This is what you will configure on the customer edge router. Now let's configure provider edge router. How I will configure BGP for VRF A, router BGP number 500, address family IPv4 unicast VRF A, and here I will say neighbor 12.1.1 and remote AS 100. On router number 4, router BGP number 500, address family IPv4 unicast vrf a and neighbor 45.1.5 and remote AS 100. That's it. Now I am expecting BGP neighborship. Here you can see BGP session. On router number 4 also soon you will have BGP session. You can see router 1 is advertising this prefix. It will advertise this prefix soon to provider edge. Both the customer edge router are going to advertise LAN prefix to provider edge. 1 minute. 1 minute guys. Okay, now this prefix is valid as well as best. So go to provider edge router P1. So IP BGP VPN v4 all. Here you can see we have this subnet 10.1.1.0. Similarly on router number 4, this is the prefix of side 1. On router number 4, so IP BGP VPN v4 all 20 subnet. But how P1 and P2 are going to advertise these prefixes, guys? Through MPBGP session. So now we need to configure MPBGP session between router 2 and router 4. How I will do that? Router BGP 500 neighbor 4.4.4 and remote AS 500. What is this? This is BGP neighborship for IPv4 address family, but I need to configure BGP session for VPN v4, that is MPBGP. So address family VPN v4 unicast and neighbor 4.4.4 activate. By default, neighbor is activate only for IPv4 address family. For all other address family, you have to activate neighbor manually. Now on router number 4, I will do same thing. Router BGPS number 500 and neighbor 2.2.2. Neighbor 2.2.2 remote AS 500 address family VPN v4 unicast neighbor 2.2.2 activate. Now both the routers are going to exchange customer prefixes. First they will have neighborship. So IP BGP VPN v4 all summary. The neighbor is idle. Why neighbor is idle? Ping 2.2.2 and source 4.4.4. Ping is working. Neighbor should not be idle. Neighbor is idle. We have to troubleshoot the issue. Can anyone tell me what is the issue? Anyone? Why this neighbor is idle? So IP BGP summary for IPv4 also neighbor is idle. Why? Update source loop back 1 guys. Router BGP 500 and neighbor 4.4.4 update source loop back. Sorry, here neighbor 2.2.2 2 loop back 1. On router number 2 also I have to run this command neighbor 4.4.4 and update source loop back 1. Now neighborship is up. So IP BGP VPN v4 all. Now you can see on router number 2 on provider edge we have 10 as well as 20, right? This is BGP, we all know this. Router number 4 will also have both prefix in their BGP table. So IP BGP VPN v4 all. Great. But customer will not have route of other site on router number 1. So IP route BGP I don't have route because of same AS number. So here I can add one more command, allow AS in router BGP number 100 and neighbor 12.2 allow AS in, and on another side router BGP number 100 neighbor 45.11.4 allow AS in. Now so IP route BGP. Now you can see in side 2 we have side 1 subnet, and in side 1 so IP route BGP we have side 2 subnet. Prefixes are there, but if I will ping, if I will test communication connectivity, then there is no connectivity. Why there is no connectivity?
R3 don't have the route.
R3 don't have route, right? Router provider router. Here I have single provider router. In your case, you can have multiple provider router. They don't have route. So now here you will enable MPLS. After enabling MPLS, see what will happen. Go to R2, config T, interface F1/0, MPLS IP, R2, interface range F0/0 and F1/0, MPLS IP, and R4, interface F0/0 MPLS IP. Now check connectivity and verify the packet flow. Ping is still not working. Soon LDP session will come up. LDP session is still down. LDP session is up here. Sorry, it's up on router number 2. LDP neighbor 3. So LDP neighbor 3.3.3 on router number 4. Now ping should work. So run interface loopback 1. Ping is working. Check packet flow now. What will happen? When user will generate traffic, user will generate normal IP packet, source IP 10.1, destination IP 10 dot, sorry 20.1. It will send, user will send traffic to their C router, custom managed router. R1 is going to compare destination with routing table. So IP route or so IP SAF 20.1.1. See, exit interface is fast Ethernet 1/0, next hop IP address is 12.2. It will look up for ARP table and then it will send traffic to R2. R2 is again receiving normal packet. R2 is going to compare destination with SAP table. So IP SAP 20.1.1. On R2, route is not there. So IP SAP 20.1.1. No route. Why? Because I am checking SAP table for SAP table in global table, not in the VRF table. So IP SAP VRF A and then 20.1.1. Here you can see there are two label, right? Router 2 will understand, okay, like MPLS is enabled on my exit interface, so I need to attach MPLS header here. Router 2 is going to attach MPLS header here. Now if you will capture this link, and then generate traffic, this is my old caption. Stop, start. See, if I will open any ICMP packet, see how many MPLS header are there. There are 2 MPLS header. S bit in this MPLS header is 1, S bit in this MPLS header is 0. It means this MPLS header is not the last MPLS header. Router will receive traffic at physical layer. It will check traffic in this way, right? From this, in this way, top to bottom. First Ethernet header, then this MPLS header. Here S is 0 and here S is 1. Means this is last MPLS header. This is not last MPLS header. From where 2 label is coming? Why we have 2 label here on router number 2? See, if you will check, so IP route VRF A and 20.1.1, 20.1.1 in VRF A routing. So IP route VRF A.
So, and R2 you can
So IP route VRF A. 20 subnet is reachable from 4.4.4. Now router have to look up the routing table again, right? Because to send traffic to 4.4.4, what will be the exit interface? So one label for 4.4.4, one label for 20.1.0, one is for next hop. So MPLS forwarding table. Here you can see the label 305 for 4.4.4 and 4024 20. So 402 and 305. Is these two are the label? 305 and 402. 305 in the inner or outer MPLS header. 305, which is the next hop header. So R2, okay. R2 has attached this label and simply R2 will send traffic from fast Ethernet 1/0. Right? It will add 2 label. MPLS 305 and MPLS 402. It will send to R3. R3 is P router. P router is receiving labeled packet or unlabeled packet? Labeled packet,
yes.
right? First it will check Ethernet header. Then it will check this MPLS header. In this MPLS header, what is the label? 402. It will compare that with their forwarding table, MPLS forwarding table. Where is 402? 402 local label.
So that is R2 only. You can open R3.
R3. So MPLS forwarding table. Yes. Label 402. Is local label there? On R3? No. R3 cannot. Yes, here it is. It is inside inner MPLS header. In outer MPLS header, label is 402 and there is no any local 402 label. Correct guys, on R3. And router 3 will also check S bit is 0, means it is not last MPLS header. Router 3 will check inner MPLS header. In inner MPLS header, label number is 305. It will see 305. Outgoing label is pop the label. R3 will remove all the label and it can forward traffic to 4.4.4 from fast Ethernet 1/0 from this interface. So R3 don't need to check routing table to take forwarding decision here. This way both the sides are able to communicate with each other. If you will configure this, capture both the link, this link and this link, and try to understand the packet flow, you can understand complete L3 VPN. Guys, this is the most important part of MPLS or service provider network. Earlier we had already discussed how these two sites are going to exchange routes and how service provider is going to manage multiple customer. But if MPLS is not enabled, then sites was not able to communicate. After enabling MPLS, site was able to communicate. Now you know what actually happened after enabling MPLS. Now what I want you guys to design this lab. Design a core service provider network. Take one P router here and multiple provider router, at least 3. This is another P router, or you can make it some simple. Here take one router and connect some customer to two different customer here. Between P to P you have two path. Or why only two path? Because the service provider is connecting multiple customers. There should be multiple path. If there is any issue or any maintenance work is going on one path, there should be reachability. So this is core service provider network. Here you will configure IGP first. Why? To make reachability between loopbacks. And then to VRF, enable MPLS on this all router and check both the customers are able to communicate or not. If you want to make it complex, then you can add one customer here also and another side of same customer here also. Like this. So these two routers are also PE. PE, PE, PE and PE. Let's say customer A, customer is side 1, side 2, customer B, side 1, side 2, customer C, side 1 and customer C, side 2. You can also do one thing. You can here add one more side of customer A. Customer A has 3 sides. Customer A side 3. So see, now in this scenario you have to configure BGP session between this and this P for customer A, as well as BGP session, MP BGP session between this P and this P and this P. So service provider is going to create multiple VPNs, multiple VPN over here between all the P router. One VPN over here, one VPN over here, one VPN over here, one VPN over here. One VPN can be over here as well, so that side customer A side 1 and side 2 can directly exchange routes. These are complex scenario, real-time scenario, which you can design and configure right in your EVNG, but the configuration is going to be exactly same. I have one more advanced scenario that I will discuss, and there is a configuration of L2 VPN that we will discuss. But guys, today I am not able to speak properly. Okay, so I had already told you in beginning that today I will take class for 1 hour only. So I will discuss that in next class. Till then you guys can practice this topology, like 2 side, 3 side. And if you have understood this properly, if you have checked all the packet flow over here, you can understand this as well without configuration. But if you will configure, it will be better. You will understand more. Okay, sir.
Please share today's and yesterday's videos, sir.
Yesterday recording is already here, brother, in group. Yesterday recording is here, na? Yesterday I shared the recording. I will definitely share
Uh,
today's
I,
recording.